Hi everyone, a very good morning to all. Now we are going to study the question number 77, that is photoelectric effect. What is photoelectric effect? See, when electron emitted, that is called emission of electrons. When electron emitted from metal surface, when light falls on it, light energy falls on it, then it is called photoelectric effect, and the emitted electrons are called photoelectrons. So this is what the definition of photoelectric effect. Now for such photoelectric effect to occur, photon energy E equal to h nu equal to hc by lambda is greater than or equal to pi. Then E minus pi equal to k maximum, or h nu minus h nu naught equal to k maximum, or hc by lambda minus hc by lambda naught equal to k maximum equal to EV naught. Now we have seen same thing in last lecture also. Now, how to understand experimental study is when you consider one vacuum chamber, like you consider there is a circuit. This is like cathode, this is like anode. Now light falls on this one, so through the transparent one, so that the electron will emit. When electron emits due to photoelectric emission or photoelectric effect, the electron may come out with the zero velocity or maximum velocity or any velocity. So few electrons will reach the other end and they constitute current. So even though the anode potential is zero. So that is what we represent here, that on y-axis and x-axis we take anode potential, and even though it is zero, there is some current you will observe. So when you start increasing the anode potential, the current also increases and it becomes saturated. And when you start giving the negative potential to anode, then the current decreases, and at one particular point called negative stopping potential, the current becomes zero. That only we call it as stopping potential. And the stopping potential means negative potential you apply to anode so that the electron with maximum kinetic energy can be stopped. That is, K maximum will become EV naught. So here also you will understand that photocurrent is directly proportional to intensity. So as you change the intensity, then photocurrent also changes, because intensity depends on number of photons. So intensity equal to NH nu. So number of photons, more number of photons, more electrons, then more current, photocurrent will come. Now, based on that thing, when you consider, so different graph based questions they will ask. Like if you consider, suppose this is one graph where all have same saturation current, means intensities are same. But here EV naught equal to h nu minus pi. So as V naught different, nu is also different. Like if you consider nu1, nu2, nu3, then nu3 greater than nu2 greater than nu1. Greater frequency means greater stopping potential will be there. Or else same stopping potential but different saturation currents, means the intensities are different. Then here intensity I3 is greater than I2 greater than I1. But nu1 should be equal to nu2 should be equal to nu3. Same light with different intensities. Or else when you consider EV not equal to h nu minus pi, so V not equal to h by into nu minus pi by E. When you try to draw a graph between stopping potential on y-axis, frequency on x-axis, then it is just like y equal to mx minus c. So straight line having negative intercept like this with positive slope, and if it is theta, then slope equal to h by e and intercept is equal to pi by e. So like that, they can ask the graph between stopping potential frequency or kinetic energy maximum frequency, anything they can ask. So when they ask the graph, you need to understand what graph they are asking and between which two quantities they are asking the graph, whether we can find any data from the slope or whether we can find any data from the intercept, we have to think it properly. Like, let's take few examples based on whatever we have studied. In an experiment on photoelectric effect, the slope of cutoff voltage versus frequency of incident light is found to be. So just before I have seen cutoff, the slope of cutoff voltage versus frequency of incident light. So V naught versus frequency, same thing. Slope means what? H by E. So slope of V naught versus frequency is equal to h by E. Now h by E value they have given as 4.1 into 10 power minus 15 volt second. Calculate the Planck's constant, where E value is how much? 1.6 into 10 power minus 19, coulomb. Just substitute and do the multiplication. Now here is another question. The given graph shows the variation of photoelectric current I versus applied voltage V for two different photosensitive materials and for two different intensities of the incident radiations. Identify the pair of curves that corresponds to different material but same intensity of incident radiation. See here, first you have to decide which are 1, 2, 3 and so on. See, let's take, this is 1, no confusion. But this is 2. Now this is 3 and this is 4. Now when you consider 1 and 3 have same saturation current. That means intensities are equal but different material, because the stopping potential for 1 and 3 have same saturation current, so intensity is same, and stopping potentials are different. See, this is the stopping potential for 3, this is the stopping potential. V1 is greater than V3. So that nu1 is greater than nu3. Now we have to identify the pair of curves corresponds to different material but same intensity. So this is the answer. So their saturation is same means what you can conclude? They are having same current. Even same way when you consider 2 and 4. 2 and 4 also same saturation. That is, intensities are same. But again, different material. So that is what? That is the way you need to understand. Like saturation current same means intensities are same. And stopping potential is same means frequency is same. So depending on that, you need to understand. Now one more question. Here, again V naught versus frequency. What they are asking is, which one of the two has higher value of work function? See, a work function means See, when you consider V naught equal to H by E nu minus pi by E. So, the intercept will become pi by E. Here, intercept for metal B, when you consider only this one. This is the intercept for B. But intercept for A is this one. Now, intercept is more means work function is more. So, intercept for A is greater than intercept for B. So that work function for A is greater than work function for B because E is same for both of them. Now draw a graph to show the variation of stopping potential with frequency of radiation incident on a metal plate. How can the value of Planck's constant be determined from this graph? So already we have done graph between V naught versus frequency is straight line like y equal to mx minus c form. V naught equal to h by e nu minus pi by e. Therefore, slope equal to h by e. So from the slope, we can find. If you want to find the Planck's constant, you can find slope. And if you want to find the work function, you have to take intercept. Now, one last and final question. In an experiment on photoelectric effect, the slope of the cutoff voltage versus frequency of incident light is found to be. Calculate the value. So it is similar, same question I think copied. So you understood what kind of questions will come. So just see here, like instead of stopping potential, they have given K maximum. Like when the graph is between K maximum and frequency, then K maximum equal to H nu minus pi. Now this is on y-axis mx minus c. So then the graph will be similar kind of graph, y equal to mx minus c, but slope equal to, now it will become, slope is only h and intercept will become pi. Like that, depending on the graph, the slope and intercept may change. So which two quantities they are asking, then what is the relation between them, what quantity to be taken on y-axis, which quantity to be taken on x-axis, you have to understand and you have to analyze properly. So this is how the questions will come based on the graphical analysis or experimental study of photoelectric effect. So practice all these exercise questions, then you will get the idea. So thank you all. We'll continue in the coming session. See